here. And talks about an object. Please stop kicking the cabinets. I know it's nervous twitch, but tells us about the acceleration and for a certain time, and at the end of the time, it has this velocity, and it wants to know what the initial velocity is. So in the y, you should show some understanding of, let's see, acceleration definitely. You know, show that you understand what acceleration is. So acceleration is, say, the rate, velocity changes. And let's see, what else do we know from there? I'm looking at it and saying, okay, it's changing at a rate about 5 for me, about 5.5 meters per second every second. You know, 5.47. Remember, you can work on the side computers. Feel free to use those, you know, to work on your own problems and such. If you're on, in a minute I'll cast out my screen on as a window, so you can also watch maybe easier up what's going on. And it accelerates mine for about 1/5 of a second. So I'm expecting mine to change probably less than 2 meters per second. All right. So I'm gonna go out on a limb and say that the velocity will be positive at the beginning. Excuse me for 1 second. Put that out of your way. All right. So and that's really about all I would need for my y here, because it's a pretty I think that covers everything. So for my how, I'm going to start off with my equation of v final equals v initial plus a delta t. That can be found on our equation sheet, right? And so now I'm going to fill in what I know. Let's see. What I know I end up at 9.41 meters per second. So that's my v final, positive 9.41 meters per second. I don't know what my v initial is. My acceleration, they tell me that my acceleration is 5.47 or positive 5.47 meters per second squared. So 5.47 meters per second squared. Well, that's good because my other units were meters per second. So as long as my time's in seconds, I'm a happy man. And it is 0.222 seconds. Cool. 0.222 seconds. Oh, now I just do a little math, right? So I have one variable left. And I find my final velocity. And all my units cancel out nicely. Mine was 0.222 seconds. Yours is probably different. You should check yours out to see what it is. Right? Yep. Any questions on that one before we jump into the next one? You guys can do that a little bit of algebra, right? Okay. If you need help, give a call. But I'd like to try to get as many done as we can today. All right. Let's pause. All right. So the 11th problem here, and it asks, how far does a freely falling apple drop in 6.2 seconds after being released from rest? what does it tell us when it says that it's released from rest? What does that tell us about?
Starting velocity is 0.
Its starting velocity is 0, and because it's freely falling, we know that it's accelerating at what rate?
9.8.
Close to 10. We're going to use 9.8 meters per second squared, but right, close to 10. So they tell us it starts from rest. So those are good things to show you understand is the apple starts with a 0 velocity. It accelerates downward at 9.80 meters per second squared. Or you could write little g there. And then I'd probably add in there, just to show I completely understand how far it falls depends on how long it has, on how long time it falls. And this is one, although not required, I might try to make sure I completely showed my understanding by drawing a force diagram. So I would draw my apple, and then I would say, okay, well, I know that the only force on it is its weight, and it's accelerating downwards. You don't have to, but it shows that you completely understand it. You know? Yeah, it would definitely be something that I would look at. You know, let's say that you had perfectly what I wrote up here in black. You'd get full credit. If you missed a point or something in there and you had the drawing, you get full credit. All right? So, and it's actually the drawing that tells me that it's accelerating at 9.80 meters per second squared. It's the logic from that drawing. But you guys can no, it's that you can't have equations. You can have values.
So if you think it accelerates at 9.8,
yeah. And you could also say it accelerates down at little g. You know, the acceleration due to gravity. Yeah. So then equation-wise, I'm going to actually use that my main equation down there equals d naught plus v initial delta t plus 1/2 a delta t squared. That's right in the bottom box of our equation sheet, right in the middle. So, let's see. I think I'm going to add some stuff to my drawing. Which direction you guys want to call positive?
Down.
Down? Okay. So we're going to call down positive. Okay. Where do you want to say a height of 0 is? The bottom. Okay. So we're going to say this is 0 meters. So that means this is going to be some negative height. That's okay.
Wait, can we undo all of that? Because I like thought of it. I don't want to.
No. It's actually going to make life easier. Don't worry.
That's what I meant.
It's all going to come out. So we're going to call this height here negative h, because it's upward, which is negative, and it's at a value of h. So what we're actually looking for is the value of h. We're looking for, because it asks us how far does a freely falling apple fall from rest? Well, it's going to fall from negative h to 0. So how far has it fallen? H. Does that make sense? Yeah, we could have called that Bob. And then if it fell from Bob to 0, how far is it falling? Bob. Yeah.
It doesn't matter.
Doesn't matter what we call it. But it helps to name it so we can put it in our equation. Because remember, this is where I end up, is where I start, and how fast I'm moving, things like that. So I end up down at the bottom at 0 meters. I started at negative h. How fast was I moving at the beginning? 0. So what's 0 times delta t? 0. So I can put 0 in there. Plus 1/2. Now I'm accelerating downwards. So it's downwards we said is positive. So I'm going to put in positive 9.80 meters per second squared. And my time, what they tell me, 6.2 seconds. Squared. Okay, so let's see. I need to bring I want to get the h on the other side so I can solve for it. What happens to the negative h if I bring it on the other side? Positive. See, Liam, no worries about the positive negative, right? And that h equals 1/2 times 9.80 times 6.2 seconds squared. Ah. And you can find h, and h is what they're looking for. Because that's the difference between where you start and where you end. So that's how far you've fallen. Any questions on that one before we take a minute and then go on to the next one? Yeah, Jack. Because I looked at my equation sheet, and it was the only one that involved time and distance and acceleration. And because I looked at it and said, oh, that means where I end up is where I start, and how far I traveled because I was moving when I started, and how far I traveled because I accelerated during that time. And they asked me about how far I traveled because I was accelerating for a certain amount of time, so it seemed to fit with that equation. I mean, some people would look at it and say, well, I picked the one that I knew the most variables out of. And that can work. I prefer to look at it and say, okay, this is what the equation means, and this is what the problem means, and match them up that way. Whatever makes better sense to your brain. Liam, you had a question?
I agree.
All righty. This is a good one to do because this one if this is on like the test that's coming up next week, you would need to do a force diagram for this one to get credit for a Y. It is number 7 or 3.39. You're looking at them through their numbering scheme. So
their numbering scheme like existent, or do they just like pick some numbers?
no, it refers to this is also in your textbook in chapter 3, problem 39.
Really?
Yep. Yeah. These are problems from your textbook. Yeah.
I did not know that.
Okay. Hey,
Now
you do.
My world has been.
Hey, that's something you can put on your exit ticket.
Mr. Cochran.
Something you'll learn today. Yes, sir.
We should call this site the book site.
The book site?
I think we do
Okay.
call it the book site.
That was pretty good.
There you go.
Especially for a Friday. That was really good. All right. So we have baseball player is dashing towards home plate. So it has a speed. She decides to hit the dirt slide for this long before reaching plate as she stops. What is her acceleration? And how far does she slide? Actually, looking at this one, we don't need to do a force diagram. Sorry, I was misinformed. I thought they wanted you to look at her acceleration and figure out the amount of force from the amount of force that she exerted. But they don't tell you anything about her inertia. So they're thinking, their thought in the problem was about acceleration and distance and time. So this would actually be this is going to be very similar to the previous one. One change, I would say, would be the acceleration is opposite motion. Slowing down. What's her final velocity? Is 0, yep. She stopped. That's a double P in there. And I might put in something to show. I could do a diagram for this one, right? Let's see. We'll draw her. Now, remember, your drawing doesn't have to be as good as mine. There she is. You like that one? And she'd be moving in this direction. She'd have a weight down, a normal force up, and a frictional force in that direction, and her acceleration is in that direction. Okay, well, we'll give her feet. How about that? Maybe a head. Okay, there we go. She looks like she's in a sleeping bag. I might actually add in the line here, the more acceleration, the faster, hate that word, she stops.
To change it to more.
Yeah. And let's see. Let's see what I know about. I know about how fast she's moving when she starts and when she ends. And I know she slides for this much time. And I want to know her acceleration. So I know a lot about how her velocity changes and the time. So I look at my equation sheet and I realize, oh, the equation talks a lot about your velocity and your time and your acceleration. Oops, that should be a plus. Plus a delta t. Right?
You know where final velocity is?
0. Mine initial was 3.2 meters per second. I don't know her acceleration, but I expect it's going to be negative, right? Because it's opposite her motion. So if I get a negative answer, I'm going to be happy. And they told me my time, 1.2 seconds. And I'm going to solve for A, and I'm going to get negative 2 point something. Let's see. Negative 2.667 meters per second squared, which I would report as negative 2 point, how many sig figs do they want? 2. So in 2 sig figs, 2.7 meters per second squared. I divided them. I'm not.
You just have to rearrange.
I brought the 3.2 on the other side, which made it negative because they're added together. And then to get the A alone, I divided both sides by 1.2. Remember, anytime the algebra looks hinky or you don't know how to do it, try throwing in easy numbers like 2s, 3s, 5s in the place of the numbers and see if it makes sense when you rearrange it. Numbers that you can like do in your head. You know, like I throw in 6 and 2, and if I didn't get the answer of 3, I negative threat, something would be wrong. So. And then part B, how far does she slide? Now, I can do that with the equation I used before. I'm going to use a different equation just to give you an alternate way. So you could go and look at the one we did just a minute ago and use d equals d naught plus v initial t plus 1/2 at squared. Or you can look on the equation sheet and also see this, that v final squared equals v initial squared plus 2a delta d. That's on it in that same, right next to the equation we used on the top.
Delta D.
That's how far you travel. That's your displacement, which is what they're asking for. Yeah. So our v final is 0. Our v initial is 3.2 meters per second squared plus 2 times negative 2.7 meters per second squared, and delta D. And I'm looking for delta D, so I'm going to bring, let's see, what's 3.2 squared? Let's see. 10.24. So I'm going to bring the 10.24 over on the other side and make it negative 10.24 meters squared second squared equals, let's see, 2 times 2.7. 2 times 2.5 is 5. And then the 0.2, 5.4. Negative 5.4 meters per second squared delta D. And then I should get a delta D of, oh, wait a minute. Maybe I shouldn't use the 2.7. Because that's a lot of rounding, isn't it? What should I use rather than 2.7? 2.6666. So if I have it in my calculator, I should probably use, I multiplied 2 by 2.6667, which right now I'm going to say is, let's see, 2 times that number. And I get close to that, negative 5.333 meters per second squared. And now if I do 10.24 divided by that number, I get 1.92. How many sig figs do they want? 2 again? So I get 1.92 meters. They want 1.9 meters. Sometimes. I've had a couple times to kick it out when there was, with a couple other problems. Let me try them. All right, we're gonna do clear the runway, but as requested, we're gonna start with part C. So I was just double checking that I had my correct answers for part A and B. So we'll start with part C here on clear the runway, and just for time, we'll assume that you have a nice Y talking about the things that we just talked about in all the other ones. I should say clear, shouldn't it? So we're going to start with part C here. All right. So, what is the distance first traveled by the plane in the first second of its run? Okay. So, in the first second of its run, I'm going to use D equals D naught plus V initial T plus 1/2, V initial delta T plus 1/2 a delta t squared. And I'm going to call where the plane started 0. Okay? And so I want to know where it ends up after 1 second. That'll be d. It's starting at 0. What's its initial velocity starting from rest? 0. So 0 plus 1/2. My plane is accelerating at 5 meters per second, I think it said. Oops. Helps I'm not drawing when I'm trying to scroll. 5 meters per second. So 5 meters per second squared, and it's traveling at 1 second for 1 second, right? So I'm going to square that. Oh, let's see, I may be able to do this one in my head, right? 1/2 times 5 is 2.5. 2.5 times 1, 2.5 times 1, 2.5. I should check it. Kidding. So mine should be 2.5 meters. Double check just because it's Friday. You never know on a Friday. 3 sig figs at 2.50. And now we're going to go on to part D. I'll be back there in a second. And in part D, they want to know how far it travels in the last second. So now the one problem is that in the last second, it's already moving. I'm going to use the same equation, but it's already moving at the beginning of it, right? So, but I don't know what that is. I know that at the end of this second, it's moving at 134.164 meters per second. Because I answered part B, right? So what I'm going to do, this will be part D. I'm going to use red. But first I need to figure out how fast is it going at the beginning of that last second. So what I'm going to use is that V final equals V initial plus A delta T again. You guys seeing kind of how we're using the same equations again and again, right? Because they're the same concepts, same relationship. I know my plane gets up to 134.164 meters per second. That's my answer to part B. I don't know how fast it's going at this initial velocity, but I know my acceleration, 5 meters per second squared. And how long does it have to accelerate in this last second? How much time does it have in the last second to accelerate?
1 second.
1 second.
It's just worked a little bit.
I know. Oh, wait a minute. 5 times 1 is 5. Something plus 5 equals 134.
So 134.164 minus 5.
So I end up with 129.164 meters per second. And that's the velocity of my plane just as it starts this last second of travel. I answered part B. So my 134 was my answer to part B. And now I'm going to use D equals D naught plus V initial delta T plus 1/2 A delta T squared again. Let's say. No, I'm still on part D. Part D says how far does it travel? I realized I needed to know how fast it was moving at the beginning of that second. Yeah. And it said what? For what? Congratulations. I'm going to show how to actually do it, though. Okay. Because it doesn't ask how fast I'm moving, does it? No. So I'm going to call where it starts this at 0 again. So D equals 0 plus, and Michelle, what you hit is it's what is called luck, and you're going to see why. Okay. Dina, my V initial is my 129.164. I better move all of this over because I'm going to run out of space. I can already feel it. My time is 1 second plus 1/2 5 meters per second squared times 1 squared. Oh, so that's 129.164 meters plus 2.5 meters. So let's see. So 131.664 meters, or with 3 sig figs, 132 meters. Let's see if that works. It is Friday the 13th. All right. Part E. What percentage of the takeoff velocity did the plane gain when it reached the midpoint of the runway? Now this one, you could do this mathematically, but if we put a little extra thought into it, the acceleration is the same every second, right? Mine's getting 5 meters per second every second. So, but did we reach the midpoint of the runway halfway through the time? No, we reached midpoint of the runway more than halfway through the time. So we need to figure out the amount of time it took to get there, and then we can talk about what percentage it gained. Or we can figure out how fast it's going at the midpoint and look at that compared to how fast it's going at the end. I think that'd be the easier way. Yeah. Halfway down the runway distance-wise. Like my runway, I think is 1,800 meters long. How long is yours? 18. I think that's the same for everyone. So we're looking at 900 meters down the runway for part E. I don't know, whatever you put in. You know our numbers are probably different. All right. So we're looking at the 900 meter point, and I'm going to use V final squared equals V initial squared plus 2A delta D. And what I want to end up finding here is V final over my complete speed, which, right, is 134.164 meters per second. And then that's multiplied by 100% to figure out a percentage, right? Remember that from like the traffic study things?
Yeah.
So my V final, I want to know. I don't know it. My V initial, how fast is the plane going at the start of the runway? 0 squared plus 2, 5 meters per second squared, 900 meters. Do that, find V final, put it in over here, figure out your percentage.